Great. Well, today we released version 11.2 of Wolfram Language and Mathematica. I think the story of my life is told in version numbers. Mostly, I would say the integer version numbers are the big points, but the point one versions are also pretty interesting. A lot of times, by the time you have a 30-year-old, nearly 30-year-old software product, and you're releasing a point one version, you might think, "Gosh, there can't be anything interesting in this." But the thing that's been really exciting for us is that we've just kept on building more stuff, and as we build more stuff, we're able to build even more stuff even more quickly. And this has been a terrific accelerating process over the years. So we released version 11.1 in the spring around April, and what we do is we have this that we're always developing, and the idea is we release point one versions as soon as they're kind of ready and cooked, and it's and then we the kind of integer versions are the kind of big news stories. The point one versions are the latest stuff that came off the R&D pipeline. So this is 11.2. Here's a word cloud of kind of the sort of notable features of 11.2. It's kind of one way to measure these versions is how many new functions are there. In version 11.2 there are just over 100 new functions, which is a pretty big deal really for something that's just a point one release. Anyway, so I wrote this blog post, posted it today. It's got a bunch of information about different kinds of things that are new in version 11.2. I thought what I'd do here is just play around with some of these things. I'm sure the best way to find horrifying bugs is to actually do stuff in public, so maybe we'll find some of those. And I'm sort of hoping we'll just have a chance to play around, and I'm very happy to kind of answer questions, try and do things on request and so on. Let's make this, I don't know whether we need to, but I'm going to make this 125% magnification, and let's see where we start. Let's see, dollar version, that's always a good place to start. Okay, 11.2, September 11th, okay. It's a big QA process for us. In these new versions we've got, this is Wolfram Language is something lots of systems rely on, and it needs to really work great, and that's takes a long time to test it, and we've got a really good process these days, all built in Wolfram Language, I might say, for doing that kind of testing. Of course, as I said, we'll find bugs. Well, let's see, where should we start? We could start with, here's a fun thing. So let's get a picture. Let's just get a picture of a rhinoceros. I don't know why I always seem to pick on those animals. But let's so this is just using natural language, understanding standard stuff. Okay, there's our picture of a rhinoceros. Let's do something. Let's ask for Van Gogh's Starry Night. Let's say Starry Night painting. And again, let's see, artwork. Okay, let's see whether we can get an image of that artwork. Yeah, there we go. Okay, the thing we might do, just as to start off, is to say let's use image restyle. That's a new function 11.2 that uses style transfer from a neural net. Let's take our rhinoceros and let's use as the style this Van Gogh painting, and let's see what happens. So I don't know how fast this will run. This is I'm not a okay, there we go. So there's a little bit of a it's at least a bluish rhinoceros. Now I think if we look up style transfer, we'll find that it has all kinds of different features and so on. So for example, got different samples. We can say target device CPU. Okay, well I wonder if I say target device GPU, whether this will go faster. Let's try that. I'm curious now. So let's say here, let's say target device. I'm pretty sure I have a GPU on this machine. GPU, let's see what happens. Could not be used. Please show you have a compatible NVIDIA graphics card. Oh well, so much for that. I could also just try saying, let's make a performance goal goes to quality. So typically we try and have these sort of automatic settings that, oh, this is kind of fun. So we see the growing rhinoceros here. We have these kind of automatic settings that let one kind of do the default thing in a useful way. So here we are restyling the rhinoceros according to the Starry Night painting, and we're actually seeing the progress here, and we're seeing rhinoceros or the emerging Starry Night, depending on what one's looking at, from the system. I might say that the whole thing here is this is based on a neural net system, and we'll talk a little bit about the symbolic neural net framework that we've been developing for a while now, and that's becoming increasingly mature. Lots of new things in it in 11.2, and actually some even more things to come in the next probably a few weeks or a month with our neural net framework. It's kind of fun because, you know, machine learning and neural nets, deep learning and so on are in their sort of hypergrowth phase. I've seen maybe a dozen fields in my life that have gone through this kind of 5-year or so hypergrowth period, and it's always fun because, you know, there's a serious new thing being discovered every 2 weeks. And what we've tried to do is build a framework where we can sort of surf that wave and put them in the Wolfram language and make it so that people can really make sort of production use of those things as quickly as possible. I can keep talking for ages here, but there's an emerging rhinoceros, and I don't know what to do with it. But we're only at 32% complete. But we can stop it and just see how much of a rhinoceros has emerged here. Okay, there we go. Well, it's kind of a squiggly rhinoceros. But let's try looking at a few other things in the symbolic neural net framework. So actually, we could look up net model. So this is something that will actually be built out a lot in the near future. This is a system that allows us to have this is a way of kind of getting actually here. Of course I can never be content with showing things which actually exist. I have to show things that don't yet exist. So I'll show you something which doesn't yet exist, but will soon. This is a repository of neural nets. As I say, it doesn't yet exist. You shouldn't be looking at this, but anyway, I'm going to use it myself. And it's the things that are in here are accessible already from version 11.2. And let's see, what was I going to do here? I was going to do this. I was going to say, here is a network. Let's get this. Okay, so this is a network. This is an interesting network. So this is a typical example of our symbolic neural net framework. The model is stored in the cloud, and this is a symbolic representation of the model. And then let's say a net model equals that. Okay, great. So this is a symbolic representation. We can drill down. We can see all the model if we want to. We can study every microscopic detail of it. It's got lots and lots and lots of stuff in it. But this particular one for identifying potential places in actually, is this the right model? I think this isn't the right model. This is not the model I was looking for. This model is fun too, but let's do this. Let's say let's do this. Let's say web image search for, let's say, sand dunes, and this is just going to use an external image search API. Let's say thumbnails of sand dunes, and then we're going to say to this neural net model, okay, let's pick up one of those sand dune pictures, which I called net model NM. I'll say, what can you tell us about the sand dunes? Okay, it says it's desert and sand. It's kind of, we can always interrupt it sort of part way through. We could just take a part of this. Let's go take, I don't know, 10 levels of the neural net model. And it's always kind of interesting to see, let's say, that applied to the sand dunes. And let's see what it looks like there. we'll probably get some huge mess here. Let's see what happens if I just say image of that. Okay, so this is showing us kind of the internal thinking of the neural net when it's pondering this sand dune, trying to figure out what to do. It's always interesting to do a feature space plot of something like this and just see what are the different features, how are the features clustered that it's looking at. But that wasn't actually the thing I wanted to show you. I wanted to pick out something I thought might be interesting to look at here. So let me see whether I can find that neural net. Let's see what we've got here. Yeah, let's do this. Okay, so this is net model of ResNet ResNet 101 trained on YFCC 100M geotagged data. Let's see whether we can download this. Okay, so this is going to be another. Okay, so let's say this is, let's call this one GNM. So this is a geolocation identifying network. And so if let's take our sand above here, and let's just take here, let's copy them down here. Let's start a a section here in our notebook called, inferred geolocation. And now let's go ahead with our sand dunes here, and let us apply GNM to, let's say, to that picture of sand dunes. Let's say GNM of that. And now what it's going to do, hopefully, yeah, there, it gives us a geoposition. And actually what we could go ahead and do is we could say apply that net model to the sand dune picture and tell it to give us the top probabilities. Let's say, I don't know, the 50 top probabilities for where that might be in the world. Okay, so there are a bunch of geopositions and a bunch of weights. Let's see, okay, we're told to magnify it a bit more. Let's go ahead and make it wider a bit more. Let's go to 150. Okay, there we go. Okay, so these are then geopositions and the weights identified by the neural net. So it's really pretty keen on that particular geolocation. So let's say geo bubble chart now of this, and this is going to show us where in the world it thinks that picture of sand dunes is taken. So that's kind of interesting because it's kind of a it's showing us, that's, I guess, the Sahara Desert and some things like that. Let's actually, just for fun, let's just find out. Let's take that geoposition and let us say for that particular thing, let's just geo-identify what country that's in. Let's take the 3 nearest countries to what that geolocation is at. Oops. Geo-identify. What am I supposed to do here? Geo-identify. Always that would be geo-nearest. So this is going to tell us what country. Okay, so that geolocation is in Morocco. And if I wanted to, I could say geo-nearest. What are the nearest cities to that? I could say city there. Let's say what are the 5 nearest cities to the location it thinks that's taken in. And let's take a look here. Okay. Well, now I'm curious. If I go to that city, let's just take. I'm just curious what this looks like. If I say common name of that, I'll get to that name, and now I could say web image search of that name thumbnails. And I'm just wondering whether I'll get pictures that show kind of sand dunes. I might get pictures. I have no idea what I'm going to get pictures of. Okay, not very useful. All right, well, that's that city, I guess. Actually, now I'm curious. Okay, now this is the obvious thing to do. Let's take that. Let's take, I don't know, one of these there, and let's feed that to this geo-identification network. Okay. Oh my gosh, if this gives that same place, I am going to be just amazed. All right, let's say geo-nearest city. I don't believe this is going to work. Let's say 4 cities nearest there. That would be crazy if that worked. Okay. Well, it didn't necessarily work, but let's find out. Let's just find out. I'm just curious how close it is. Let's say geodistance from that position, line 25, to this city here, which it identifies. Actually, let's just do the geodistance from there to the center of that city. So we can do geodistance from that to that. Not too bad, really. Not too bad at all. Let's actually try. I'm just curious whether, if we give it that fine thing there, what it will say that is. And okay, let's try the geodistance from that. Geodistance from that to this particular city. Anyway, but this is kind of, this is just an example of a neural net. Okay, 210 miles. Now I'm actually curious, if I were to do for that image there, if I were to say what are the places, what are the top probability places for that image in the world. So I can say top probabilities, and I could say the 50 top probabilities for that, and then I could make a geobubble chart, and who knows, maybe that'll be a castle in, I don't think it's going to be Scotland exactly. Not quite sure where this is going to show up, but we'll find out in just a moment here. Wow, it's really pretty sure that's in Morocco, although it offers the possibility of something in Iran or something in Kazakhstan, am I right? So it's kind of interesting. I mean, I think it's it's remarkable how well something like this works. And this is just a neural net that it's a fairly recently produced neural net. We didn't train this one, but anyway, it's just an example of something that that we can now do in 11.2. All right, let's go look at. There are all kinds of new classifiers that have been added, like you can do, the classify the not safe for work image classifier. I don't know, let's take that picture there. This better be safe for work. I don't think there's any big problem with this one, but yeah, it's nice and safe. Although I am just a little curious. Okay, I just have to do this because I'm curious. Let's just see what happens. He says, let's do a web image search for, let's say, abstract art. And let's get some thumbnails of abstract art from the web here. And now I'm going to be mighty curious whether these are, okay, so there are some abstract art images. So let's just say, let's do this, let's say those. So now I'm just going to see for each of those, is it safe? Yeah, they're all safe. Okay, good. Well, that's fine. Okay, well, let's go ahead and look at some. So I think somebody had a question here about whether image restyle will work for videos. It is currently a frame-by-frame thing, and we are working on kind of streaming video types of capabilities. In fact, let's go ahead and do this. Let's say we've gotten as far as audio, so we're making progress. Let's see if I can do an audio capture. Not quite sure which microphone it's going to be using, but let's see if we can do an audio capture here. Hello, hello, hello. Is it capturing? Okay, let's see what I can capture here. Hello, I am capturing this on Twitch. Let's see how this works. Okay, so this will now show me. Okay, so there's a waveform there, and now let's say, for example, I can make a spectrogram of that, and this should be my. Now, okay, there we go. So this is a bunch of words and so on. I'm sure that's the Twitch. The ch is that little uptick there in that last word. So. Okay. Anyway, that's so that's what's that's roughly what the whole set of mechanisms is going to be based around the mechanisms that we use for audio. Notably, what's happening here is that audio is actually stored it's an out of core thing that's being processed there. So let's see. Other kinds of things I can do. I mean, we can do all kinds of fun. Let's see. Here's one. Here's a current. In our search for different, let's do this, current screen image. So I can go ahead and let's go ahead and just capture, boom. Let's see, there we go. Okay, I just captured an image of my screen, and now, for example, I could do all kinds of processing on this. For example, I could just say, I don't know. For example, let's say I could say, let's make a blurred. Let's just make a thumbnail of my screen. That's a simple thing to do. Actually, now I'm curious to do something. Well, here we can make a thumbnail. That's not too exciting. Let us make a blur of my screen, line 36. Let's make a 20 pixel blur of my screen. Yeah, okay, that wasn't too exciting either. That's kind of we can image process this a bit. Let's say let's take a look at it through rose tinted glasses. So let's say how about I do this? Let's say blend that with I don't know what this is going to do at all, but let's say try rose color, see if it knows what that might be. Ha ha ha. Well, let's see what that is. Let's just take a look at what it thinks that is, first of all, before we do anything else. Okay, so, oh, that's a big shame. Missing, not available, that's really boring. Okay, let's just use it as a color instead. Okay, that's just an RGB color, and now we'll have to do this with line 38, my screen image. Let's do this. Okay, that's my screen, my blurred screen through some kind of rose tinted whatever. And we could do something like, we could do all kinds of crazy things with this, but let's not. Oh, actually, yes, let's do one thing. Let's do something where we take, let me think about this for a second. What I was going to do was to try to just make a, well, here, we can do this. We could just say, we could just do this. We could say binarize. Let's do this. It's not too exciting, but it's kind of a little fun. No, I'm sorry. Let's convert it to grayscale. So we're saying color convert that to grayscale. Okay, and now let's take that and let's say relief plot of image data of that. What's this going to do? It's going to take a long time is what it's going to do, because it's probably a lot of data, because my screen is high resolution, and this is going to make some weird thing. Okay, this is not very useful. I was going to just emboss my screen somehow just for fun, oh, there we go. That's kind of fun. That's a so that's my screen as a city type thing with all its kind of yeah, that's kind of fun actually. Now the interesting question is, why is it upside down? And the answer is because the coordinate systems are opposite. That actually reminds me, talking of cities, let's try and see what happens. So another new feature in 11.2 is GeoImage. So let's see where's a good ancient city. Let's see the city of I wonder if the city of Ur is something that we know. Ur, historical country. Let's see if it's a city. Yeah, financial entity. Okay, well, there's an Ur historical country. Let's see whether we know the location of Ur as a historical country. That's not good. Is it called? Oh, let's not do it this way. Let's just ask for the geoposition of Ur. And let's see. See what's happening here. Oh, there we go. Okay, so we got a geoposition. So now let's go ahead and get a geoimage of, in fact, we can just say geoposition of Ur if we want to. And let's do a geo of, let's say, I have no idea what I'm doing here, 20 miles, for example. And so now this is going to go, okay, well, that's a bit barren, I would say. Just out of curiosity, let's zoom in on the center of this. Let's just do a 1 mile size here, just in case there's something you can see in more locally. Wow. Why am I reminded of the Ozymandias poem? Actually, now I'm curious, given that might be a structure there. That might be something real there. Okay, talking of Ozymandias, why don't we look up Ozymandias, who I think, let's see what we get. Ramesses II, a person. Okay, let's find out. I'm just playing here, but let's say birthplace of Ramesses II. Ah, not available. Interesting. Wonder whether death place is available. That is a big disappointment. Maybe it's not known. Let us see. I'm going to sort of guess. Let's imagine that he was born in Thebes, but I have no idea if that's true. That's okay. Oh, that is probably not the place we want to talk about. Well, maybe it is. I don't really know. Historical country. Okay, let's go to the geoposition of that. I'm kind of on a hunt for some kind of interesting pyramid-y type thing. Sad. Okay, let's go ahead and it seemed like we had some other place that was called Thebes, which maybe is some modern name. Let's see where that is. So let's just see what it looks like. It's in Greece, not the Thebes we were looking for. Well, how can we deal with this? Let's see whether Tutankhamen, is that how he spells his name? Okay, Tutankhamen, person. Okay, let's see where the death place of Tutankhamen is known. That is very odd. I have a feeling that might be because these things are ancient places that we don't yet have geodata for. Let's try, it's a place I visited recently, kind of interesting Wikipedia data. This was a place called Corral. Let's see just what Wikipedia has to say about it, see whether we can extract a geoposition from here. I wonder whether, actually we have, I think, a way of looking in Wikipedia for geodata. Let me just see. Blah, 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 blah. Page ID, article plain text. Primary geoposition. Okay, great. So let's see if we can get the geoposition from that place. Okay, there we go. So this was a place I visited. You can figure out geo-identify. If you don't know where it is, you can always ask, and it is in Peru. Okay, but let's take that place and let's get a geo image of that place, geo range. Let's go geo range to 3 miles. Okay, actually let's make a geo range that's smaller than that, so that looks like it's an interesting valley there. Actually, I'm now curious. We can get the let's just go geo range to, like, say 0.2 miles. Aha, ancient structures. And now, actually, let me go ahead and do this. Let us try and do some image processing on that image. Let's try doing. Let's just do an image adjust to begin with. Okay, that darkened it up a bit. So now we're on a hunt for the natural or the artificial. Actually, this is a curious thing. So the question is, can we tell that this was man-made? And let's try here. Here's a good one. Let's try Stonehenge. I just did this yesterday for the blog. If I do Stonehenge and I do geo image for Stonehenge, and let's say geo range is, let's say, let's see what that looks like. And we will find, da-da, there's a circle. And you might say, oh my gosh, that must be of natural origin. Nothing makes a circle. Well, a long time ago, let's see what I get if I do this. A long time ago, when I was working on my New Kind of Science book, I was interested. I asked a bunch of astronauts, what do you see on the Earth that sort of has the first evidence that you sort of see from space that there's some intelligence on this planet? And they said actually the number one thing is in the Great Salt Lake in Utah. There's a causeway that's perfectly straight that separates two differently brightly colored edges. But then they said another thing that's interesting is there's this circle in New Zealand. Let's take a look at that. I'm now curious to see what it actually looks like. So around Mount Erebus, let's say 3 miles, and let's see what it looks like compared to Stonehenge. Oh, that's not good. Where is Mount Erebus? Is that not in New Zealand? Did I not remember it correctly? Well, let's try 40 miles just to see whether something went horribly wrong here. Wait a minute, I've got the wrong mountain. I have got the wrong mountain. That is a mountain in Antarctica. Let's find out. Oh, embarrassing. Okay, let's see where that was. Let's just plot that on the world. Geolist plot of that. Georange to all. Oh yeah, it's in Antarctica. I don't know what I'm talking about. What is the one in? Let's just go and find out. Let's say volcanoes in New Zealand. Let's see if it interprets that. Okay, New Zealand volcano geoentities. Okay, let's see what those are. Okay, so there are a bunch of volcanoes. So which one am I thinking of? This is probably some native names of the indigenous names for the volcanoes, and I have no idea now what any of these are. Well, we can always, when in doubt, I guess we can just go ahead and do this. Let's just do geoimage of that. Georange is, I don't really know how big these volcano calderas are, but let's try 2 miles here. It's kind of nice, isn't it, being able to just, get these entities like volcanoes in New Zealand and then just sort of ask, then just kind of say, to get images. It's taking a little while to download the satellite imagery for each of these volcanoes. It's high resolution imagery. This is mostly the time we're spending here is just the stuff coming from the satellite imagery servers. But anyway, let's. Oh, I see a comment here. GPU. Oh, well, all right. Those are the volcanoes. Well, which one is it? One of these volcanoes has this weird circular patch around it. Is it that guy there? Okay, I think that's the one we're looking for. That is the volcano we're looking for. It's the 5th volcano there, which seems to have this name here. So let's go ahead and looks to me like it's a little off center there, but okay. So that volcano is so I'm now curious. If I say geoelevation data, I can get 2 miles. Let's actually just make a geodisk 2 miles around that, and then let's get the elevation data, and let's go ahead and geolist plot that. What did I do wrong? I didn't mean geolist plot. I just meant list plot 3D, because I'm now asking it to plot the thing, and that's crazy what I was asking it to do. So let's do this. Oh, well, that's a big peak there. Okay, so that's the volcano, but although I have to admit it seems to be off-center with our coordinates. It's a little bit weird and embarrassing, isn't it? So that's what you get when you compare satellite imagery with geopositions. I think that volcano is not where we think it is. So actually now what I want to do is, how would I do this? I can find the peak in that picture, and then I can try and get the location. All right, let's not go ahead and do that. Anyway, somebody was asking me about GPUs and training on Macs and so on, which don't have currently NVIDIA processors. The answer is our neural net system is based on MXNet. which is low-level library. We'll also probably have a version for TensorFlow at some point, but we're right now using MXNet, and MXNet is kind of a very nice, sleek library that is getting ported to all kinds of machines. So I think you can expect to see it show up natively on lots of machines in the future, which will be good. All right, let's talking of things showing up on different machines. Let me show you a weird thing that we added in this version. This has to do with, okay, you're inside Wolfram Language, but you want to do a computation in some other language. So, for example, let's say we do something like this, and we say, oops, that's just a string. We just say, let's evaluate in Python the string 56/80. Oh, that's so stupid. Whatever. It's not our stupidity. Okay, that's I guess I say point there, and we'll get the result. Okay. So anyway, what this did was it did. It's just using an external Python REPL to do this computation, and I could, if I wanted to, I could say start external session Python, and then I would get a Python session here. Say, you know, external evaluate, and I don't know my way around Python at all, but I could say external evaluate with that external session object, and then I could do a computation there which builds up a state in the Python system, and I could say X or something there, and I'll probably get failure. Okay, I know, of course. Okay, so for this version we're supporting Python and Node.js. We're always supporting things where we have sort of a bunch of pre-installed libraries for Python, different versions, and so on. We will also be supporting a whole bunch of other languages. I think next ones that I know of that are in the pipeline are Ruby, Haskell, maybe Clojure, basically languages that have REPLs. I mean, when it comes to supporting languages that are more function call type things, we already have, you know, good support for Java, .NET, C, C++. We're actually going to have a new mechanism for interacting with external languages like that. We also have a general way through our library link mechanism for interacting with DLLs. These are all things that we use a lot internally. As you've got an API, you've got all kinds of different mechanisms for interacting. Now, the way that this external evaluate thing works is using the 0MQ protocol. New things for sockets that are all around being able to connect to sockets through protocols like 0MQ. And I don't know how good a demo I'm going to be able to give of socket connections. Let's see, maybe I can connect to a web server. How about that? Yeah. Oh, look at that. Okay, well here, this is a socket demo. Let's do this socket demo. So I can connect. Here is a socket. Okay, socket connect. I'm connecting to that example. Protocol is TCP. That's the destination port is port 80. Okay, the source port, I guess, on my machine is that. So I could send to the socket. This is an HTTP socket, so I could send to that socket. I could write to the socket a GET request, and then, needless to say, I could read back to .wolfram.com. But let's see, we could just do this. We could read back a result. Let's just let's see. Let's just read back a result here, and let's say string take. Let's do this just for fun. Let's do a word cloud of what came back from that socket thing. And I don't know what it's going to be, but okay, most curious. Who knows what that is? But anyway, that was just the thing that came back from the GET request to that particular socket. Okay. At a systems level, by the way, one of the things that's new is being able to do native computations in iOS. But actually, let me show you something else before I do that. Let's go to the cloud. This is our Wolfram Cloud. You can go to the open version of the cloud. You can have a private cloud. I have my own private cloud. I could go to my very own private cloud here. So I just started a notebook here, And I think I could go, let's just go to view here, and let's say magnification, let's go to 150% here just so people can see it more easily. And this is now a notebook purely operating in the cloud. This is just a web browser, and I'm happy to say version number should be okay. That is an earlier version. I mean, that's the 11.2 for Linux. I guess that build got approved before for Mac that I happen to be using here. By the way, we can always go back and forth here. So I can say I could really do something elaborate here. I could set up, talking of sockets, I can set up a publish subscribe system between the cloud and the desktop here where I can start sending things. I could do, let's see, I could say channel create, I'm not sure how often I've done this, create channel Twitch test. Okay, and now what I should be able to do, let's see, that will create a channel on our channel broker. And now what I should be able to do here is to say, I should be able to listen, channel listen over here in the desktop. If I wanted to, I could say channel listen of Twitch test, and then that would be listening on that channel. Okay, there we go, message count 0. And so now I can say channel send to channel the hello there, and that should send that to that channel. And now the message count is 1, and something arrived in my desktop system. Actually, let's channel send something more interesting. Let's go ahead and channel send. Let's generate a plot of, I don't know, let's make a plot of an array function just for fun. Minus, what is a good case? Minus 10 to 10, let's say. Okay, let's make our array function here. There we go, nice array function in the cloud here. And now let's go ahead and send to the channel. Let's go ahead and send the thing that was that current result. So that will now send, so message count is 2. Now in my desktop session here, I will have received a second message here, and now I could just go ahead and say, I think it's, what is it? I have to go look this up. For that channel listener, I got to go find out what I can retrieve from the channel listener, and I could retrieve the message from the channel listener, I think. Let's see what happens if I try and retrieve the message from the channel listener. That's not what I, oh, that's a silly thing. It was line 79 message. That's, oh, great. That was, okay, so what happened there, okay, so let's actually try and, oh yeah, it's a held object, because if you just receive something on this channel, the thing is live code, and it'll explode on contact, so to speak. So actually what we want to do is line 79, and then we want to release the hold on that code because we trust ourselves, and so ba-boom, there's the picture that arrived from that channel. And so now we can do the same thing through a 0MQ socket, and that's the mechanism that we would use to communicate with these external REPLs and so on. Okay, well, let's see. I was also talking about, all right, let's switch gears completely about that to talking about, oh, let's talk about a little bit more data. Let me see here. Yeah, I'm going to close this notebook and start a new one. It's odd. Yeah, I'm going to do this. Let's go ahead and you can see all the things being cooked. This is now, because 11.2 is now released, it's the leftmost icon in my dock among the Wolfram desktop icons, and those two are creatures from the future. Okay, so let's start off again here. So let me go ahead and here, let me just save this into O2. Okay, so let's go do something a little completely different. So we're always adding data to the knowledge base, and so one of the kinds of data that we added this time around was something about military conflicts. So, for example, let us try. So that I think I learnt about in school. For this, we can say that's so this is a whole horrifying adventure of curation. But let's see, what are the sub-conflicts of the First Punic War? Okay, so there's battles of various kinds, and now we could go ahead and say geolist plot those battles. And so what should happen? Oh, that's interesting. Wow, I didn't know that was all happening around Sicily. How funky. Including, seems like, some naval battles. Okay, well that's the place. Now I'm really curious. Okay, I'm very, very, very curious. Let's take one of these battles. Hey, I've heard of this one, Agrigentum. For some reason, I've heard of that battle. I don't know why. Anyway, so let's find that battle, and let's go ahead. Okay, this is living weirdly. Let us go ahead. Let's see if that was in fact a naval battle. It let me just see. I don't know how to find out if it was a naval battle. Well, we could always just do a geolist plot of just that battle and see what it looks like. Oh, that wasn't a naval battle. Let's find out. Let's do a geo-identify on each of. Okay, we want to find out which of those battles was a naval battle. So line 2. So let's do geo-identify of country. Now I'm not sure if it's going to include the territorial waters of these things. Yeah, you know what? I've got another way to do it. Let's do geo-elevation data of, and then let's do those things on line 2. Is that going to be crazy? Let's try. Okay. Okay, let's do geo-elevation data /at %2. Okay, that's unfortunate. Okay, let's do normal of that. Okay, cool. So what we see there's a naval battle. Clearly the ones which are negative whatever feet, those were naval battles. I guess these ones we don't have precise geolocations for. That's interesting. Okay, so that naval battle, that is the, well, let's do, oh gosh, how will we do this? You know what, this is one of these things where it's trivial to count. That's the 5th, 6th, and -1st of those. Okay, so let's just do the 5th one of line 2. And let's say line 2, the 5th one of those, is the Battle of Messana. Okay, that appears to have been a naval battle. Now, I wonder if this is going to work. Oh, maybe it's not. Is that right? I thought we had a thing like a shipwreck. What do we have? What is it called? Okay, when in doubt, let's try the documentation. Shipwreck, interpreter type. Okay. Ah, I see. We can do a restricted shipwreck to the Atlantic Ocean, but I'm a little bit surprised why we can't do a shipwreck, a geo-nearest of shipwreck. Well, let's just try this. To the Battle of Messana, comma 10, for example. What is it talking about? Oh, maybe we have to say geoposition here. It's kind of annoying. It shouldn't be needed. Let's see what happens. Oh, this is funky. Look at this. What I was thinking, let's do a geolist plot here of that. What I was kind of thinking, oh wow. I was thinking, okay, maybe there's some shipwrecks from those actual, from the actual battle that took place in the First Punic War. I guess not. Now, okay, now the next question is, oh yeah, this is cool. I hadn't even thought of doing this. Let's take that shipwreck, okay? So whatever it is, I don't know what that is. And now, I wonder whether this is going to work. let us see whether, okay, the Battle of Messina, for example, let's see what that is. That is input form of that. Oh, no, silly me. No, stop. Oh, don't be silly. I just told it to disgorge the internal data associated with some giant geoplot. Okay, so it's a shipwreck. Okay, so let's try. Oh, I was doing the Battle of Messina, wasn't I? So let us try saying entity type. That's not what I want. Let's just do input form of that. Okay, it's a military conflict. Okay, now I don't know if this is going to work. Let's try it. Let's try doing a geoposition. So this is a reverse lookup, a geoposition. I'm sorry, a geo nearest of a military conflict, geo nearest, with this shipwreck. I don't know if this is going to work, but let's just try it. Oh well. Coming later. Alright, what I was going to try and do is do the reverse lookup. I mean, I could do that. I could say entity, and I could say the distance. I would construct a query here that says, find me the military conflict which has less than such and such distance. But I think this is something that should come, that should be done, and not available yet. Okay, anyway, so what I was doing here was, what was I doing here? I was showing off the First Punic War. So actually, I'm now curious. Let's pick a war that is more recent. Let's say the what's a good example? Well, I wonder what this looks like. I wonder whether that has what the sub-conflicts of that look like. Oh dear, there's probably a lot of terrible things here. Well, I'm now just curious. Yeah. All right, let's pick a war where nobody's around anymore. This is let's pick. How about the British Civil War? Don't know how many. I actually have no idea. I learnt about that when I was in school. They taught about this for some reason. I moved grades or something, and I ended up learning the history of that 3 times. I never found it at all interesting, but in any case, subsequently I discovered that all kinds of interesting things have been happening then that weren't anything to do with the English Civil War. Oh my gosh. Oh, I never heard of the Second English Civil War. I thought there was just one, with like Oliver Cromwell and all that kind of stuff. Who knows? All I know, actually, now I'm curious to do something else here. I'm going to show you something. Let's see if this works. Find geolocation. There's a thing called North Parade, Oxford, UK. Let's see if it can find that geolocation. I'm not sure if it can, but let's try it. North Parade. No? Well, maybe it isn't an official street. One of the fun things in Oxford was there, which always confused me as a kid, is there's a street called North Parade, which is south of a street called South Parade. Those were the battle lines in the, well, at least one of these civil wars. I don't know which civil war it was, because I'm now very, very confused. So let's try. Actually, now I'm curious. Let's just see whether we can make, on line 18, let's try and see whether we can make a timeline plot. I don't know if this will work, but it might. Timeline plot of %18. See if that can work. Oh, that is so cool that works. Wowee. Wow. I could have learnt all those dates in history from this. Actually, now I want to see in line 21. Let's do a timeline plot of line 21. And let's see 106 values, okay. Oh, that's not so hot. What happened there? What happened there? Well, that was shocking. Well, it worked in the first case. I wonder why it didn't work in the second case. Anyway, let's try getting for line 21. Let's do a geolist plot, and let's find out what parts of England were. That's kind of interesting. Okay, and we can probably figure out the dates. Okay. Huh. Now we could also, presumably, for each one of these conflicts, let's pick a random battle. Is there anyone I've ever heard of here? No. Well, Siege of York, I think I've heard of that one. But let's pick one that sounds like it's actually a battle. And let's see, of that battle, let's find out what the, let's just see what information we have about that battle. Let's see what we have. Okay. Oh, it does have coordinates. Huh. And cavalry, 1,000 on. So the two sides appeared to be the royalists and the parliamentarians. Okay. See, a lot of times these battles are pretty complicated to describe. I mean, if we take, let's take a battle that let's try taking D-Day. Okay. Okay, I see. So there's a bunch of sub-conflicts here. 18 sub-conflicts here. So let's say we do, no idea what this is, but let's do this one here. Let's try that one. That thing there, let's see what happens if we dig into that and look at that. Okay, so UK, Poland. I'm confused by that. I thought Poland was still part of, well, who knows? Really? Well, anyway, so there's a little bit of information here. I think let's try another battle. Let's try a sort of super famous battle. How about okay, let's see what we know about that. Still a lot of stuff that we don't know. Well, okay, so we have some information. Military killed 3155 for the US. There are its coordinates. So let's just, for fun, let's just see whether we have, let's see what that looks like now. See whether there's a visitor center there or something. So what we want to do is we want to say, actually, what we should be able to do is just say geoimage of this with georange goes to 2 miles, let's say. I don't know how big these battles were in those days. I don't know how far okay, that's the 2 mile range. Let's go ahead and let's just go to 0.5 miles, see what it looked like. And actually it's kind of interesting. Oh wow. Okay, I'm predicting there's a visitor center or something right at the center there, but let's find out. Let's just see 0.1 miles. And there we go. What did I tell you? Actually, it'd be interesting to see for like the 2 mile radius. I'm now curious. Let's do this. Let's try relief plot of geo of, let's do a geodisk. I'm just curious what the local topography was like around that battle site. Now let's do it. Let's do the thing in 3D. It's not a very high variation, but let's go a little bit into the center, and let's say 0.3 miles. And let's give it a better way of visualizing. Let's say mesh functions arrow, and okay, well, not a lot of topography, I guess. I guess it's a sort of a hollow in the middle there. We can actually, now I'm curious, if I'm pretty sure we have GeoNearest, and so now let's see what we have. I wonder if we have a park there. Do we have this available? No. Oh well. Well, let's see whether that for some reason is confused by that. Let's see if I can extract the geo position there. Oh, there we go. Cool. Okay, so that shows that indeed the Gettysburg National Military Park is in fact, and I'm sure we can find, if I do a geo list plot of that, it might have the park boundary. No, it just has a point there. It may be small, I don't know. Okay. Well, let's see. We were talking about features of 11.2. If people are interested here, we can keep going. Let's see. Well, I can try and let's just show a few more things. I should not go on too long here. Gosh, what can we show? Geometry. Here, if people are interested, let's do a little bit of a choice here. We can either talk about some language features that are sort of core language functions, or we could talk about computational geometry. We could talk about some new visualization functions. We could talk about, oh, actually, you know what? I'm sorry. I just have to do something here because I'm really curious. I have never looked at this. Let us look. Remember, we were looking at D-Day somewhere up here. Let's look at this D-Day, whatever this gold beach was. I don't know exactly what that is, but it's part of D-Day. But I am going to do something I'm really curious about. I want to look at the tides. Let us do, what was the time for this? When was that? Let's see. How do we know that? That was end date. Or maybe start date. Start date. Okay, there we go. 6th of June 1944. Okay, now let's do the geoposition of that. Oh yes, I am really looking forward to this. This is interesting. Okay, so let's say as the geoposition of that. Okay, great. Now I want to know the tides on that day, because I've been told that D-Day was timed to correspond to low tide, high tide. I can't remember which. And then I'll tell you a story about this if I can. Let's just try and see whether this works. So I want to get, well, let's first of all just get the water level by the hour. Let's just try that day. What will happen if I do that? Oh, come on. Why would that not be available? Well, let's try that day minus, and that day and let's do this by the hour, let's say. Now this may not work. Why does it say that? That is really strange. Well, I mean, there won't necessarily be a tide station at that position. I'm kind of assuming that's a beach. Let's find out if it's a beach. Okay, first basic question, is this a beach? And we can either do that from geo-elevation, or let's just do this. You know, we should have a classifier. We actually have such a classifier that tells you, given a geoposition, what type of terrain it is. Okay, hold on. Let's go ahead here and do this geo image for a geo range of, let's say, a mile, and let's see what it is. It does appear to be a beach. Okay, so now the next question is, why are we not finding... Okay, so I think the issue is probably that there isn't a tide station. Let's see what we can do here. Well, let's do this. Let's do GeoNearest. I wonder if we can do this. When in doubt, look at the documentation. Okay, so what we want to do is we want to find the tide for the nearest... gosh, how does this work? So there are a certain number of tide stations in the world, and I'm just surprised that this won't give us the nearest tide station automatically. Let me just see. Let me just see whether encompasses regions. The center of that region is used to determine the tide station. What's wrong with this? What is wrong with this? Well, let's do this. Let's see whether... No, this should work. This is only in the 1940s. There's a 19-year cycle to the tides, basically. That's the Saros cycle, the same one that deals with eclipses. I just learned all about that in studying the timing for this eclipse. Okay, why isn't this working? Well, let's just see what happens. Let's try for a tide station I know exists. Let's just try New York City. Okay, this is very obscure. I mean, there is a possibility, but it's too crazy to imagine. Years ago, when we were first getting tide data for Wolfram Alpha, we wanted tide data for lots of different countries, and in the UK said, "Oh, you can't have our tide data; it's secret." And we were like, "Huh? How can that be? The tides repeat every 19 years. All we have to do is go back and look at Admiralty tables, which are out in the public domain by now, and we'll know the tides." And so they were like, and anyway, why should the tides be secret? Who cares? And the response we got is, well, there's this thing about the tides being secret because, for fear of invasion. And that was how I learnt about this D-Day and tides business, is because the claim was it was really important to predict the tides for D-Day. So I suppose it's possible that we don't have those tide tables because they're secret. But that just seems more crazy than you can possibly imagine. How long is it here? It is a solid 73 years, and I think even the British what is it rule for declassifying documents has to have expired by now. All right, but anyway, apparently we had a vote for hearing about computational geometry. Let's look a little bit at computational geometry. So big things that we've been adding. Let's generate some geometry. How about let us do a third level. Oops, no, that's a 2D Menja sponge. Well, let's actually do that. Let's do region intersection of. Let's see how this works. A disk with that Menja sponge. What's going to happen if we do this? Okay, that's Boolean region for that. Let's see what happens if I just say graph. No, if I just say region, what's it going to do? Okay, that's cool. So that's now the region intersection between those things. So for example, if I say what's the area of that, it will, what? How can it be unable to compute the area? That's crazy. Well, let's try doing something like, how can it be unable to compute the area? Let's try doing something much more ambitious. Let's try integrating x squared minus y squared. Is this going to work? Is this not going to work? Is this crazy? Let's see whether that works. That did work. So we're integrating x squared minus y squared over that region, but why can't we say what the area of the region is? That's just weird. Wouldn't the area of the region just be integrating 1 over that region? I am very confused. Oh, no? Something's very wrong is going on here. Who knows? Let's just try a region measure, which would, I think, be equivalent to area. That's really odd. It's really odd. I don't understand that. Very odd. Notice, by the way, that that's a numerical integral. Maybe the issue is that we have to say something like the analog of n, basically, for a region would be discretized region and now we can say area of that. Oh, well that worked. I don't know why we had to do. It's kind of rude of it to not give us any clue, because basically what this is doing is there's no exact integral it can do. I'm sure if we did something like let's do this. Let's do region intersection of let's say a disk at 0, 0 and another disk at half a half. Okay, and now let's make that into a region. Okay, we can compute the area of this. Oh, wow. Isn't that cool? Okay, well, let's find out what the numerical value of that is, 1.75. Okay, so now here, discretize region, which is kind of the analog of n-ing a region, and there's our discretized region with, which has been broken into triangles, and we can go ahead and say area of that, and let's see whether it actually agrees. And let's, well, more or less agrees, 1.7523, 1.75742. So I wonder whether there must be options, which I don't know, to discretize region which tell it kind of how fine to make. Yes, so I want performance goal to be quality. Let's just try that. I'm just curious what happens if I do that. Let's try this. Okay, so we say performance goal to quality. Oh, it does the same thing. Okay, let's actually see what happens. I'm now curious if we say performance goal to speed. Oh, okay, it's not making a difference here. Well, let's try quality again, whether the area computation is different if we do quality here. I don't know why I keep on typing that word wrong. Area. No, it's the same. Okay, well that wasn't very helpful. I wonder whether maximum mesh cell measure. So when in doubt, read the documentation on options. Max cell measure using the setting. Okay, so if I say max cell measure, I'm going to guess that if I do this, if I say max cell measure, let me see, max cell measure to 0.1. Okay, that's pretty coarse. Now let's say max cell measure. I wonder whether we can do this. This would be crazy if this works. Let's try and see if we can do a manipulate to on the maximum cell measure, going from, let's not actually be crazy and go to 0.1. Let's say and let's have this go from m equals minus 2 to 0. How horrifying is this going to be? Oh, that's really pretty cool. See it re-triangulate the thing. Okay. That's kind of cool. So you see it making a coarser and coarser approximation to that thing. In fact, we can go ahead, if we want to just make a table of these, let's just go ahead and make a table here. M goes from -3 to that, and let's say steps of 0.5, and we'll get a nice table of the different discretizations. That's kind of cool. Now actually, if what we want to do here, let's do this. Let's map over that the area computation. Okay, so what we can do is we can say those minus the first of those, and that will give us the errors that we get. So these, it's interesting. So these, oh I see, they didn't change very much. It only changed the interior. It didn't change the position of the bounding triangles. It only changed triangles in the interior. So that's showing us the error building up as we change the discretization. So one of the things that happened in version 11.2 was the advance of the three-dimensional analogs of these things. So let's see what we can do here. Let us try, I always have to remember that a sphere is just a sphere, as in it's just the shell of the thing. So let's try and do a ball at position 0, 0, 0, and let's try and let's do a region intersection. So this is going to be something much more complicated. with a ball at position a half, a half, a half. This may be a horrifying thing to try. Okay, let's make the region corresponding to that. Okay, okay, there we go. So there's that region. And now we want to say, probably discretize that region. Okay, and let's see what happens if I try and find, let's say, the volume of that region. Okay, cool. So this is now, this is sort of, okay, so let's do some computational geometry with something more, a real world kind of thing. How about we do, where can we get good computational geometry from? I think we may have some in our data repository. Let's take a look. So if we go over here and we go to our lovely data repository, oh, I don't think we're marking which ones. I'm pretty sure there was some here in life science. Pacific walrus haulouts, not relevant. Rat brains, not relevant. Okay, this one, I know this one. These are very high resolution models, so I don't know. Oh, you know what? I know what I'm going to do. No, I'm going to take a simpler case. I'm going to try taking, let's try and take the left femur, and let's take its mesh region, and let's try taking, okay, this is going to be funky. May not work. I wonder what happens if I now take the right femur. Okay, that's what will happen if I do this. See, the problem is I suspect those two together are just in different places in space. So let us try and do, okay, I'm going to do something crazy. Let's do region centroid of line 74. Well, let's call this LF equals left femur, a brilliantly named variable. RF equals right femur. So now what I want to do is I want to take region centroid LF. I want to take the region centroid of LF. No, I want to do region centroid, map it over LF and RF. Okay, so that's the positions in space that those things occur at. And we can see, I guess they don't overlap. Let's just understand what happens if I just say region. Let me do this. I'm predicting that region intersection is blank because these things just don't intersect. So you know what? I'm sure that's correct. Let us go ahead and try and translate one of those things in, okay, so what we want to do is translate left femur by the difference between those region centroids. So let's go ahead and say difference. No, we want to subtract. Okay, so we want to translate the left femur by right femur minus left femur. So that's region centroid of RF minus region centroid of LF. Okay, so that's the translation factor. That's how much we have to move the. Okay, so let's take the left femur and let's. Am I doing this right? Oh, come on. How do we do this? Okay, I would have expected that to work. All right, let's try looking at region. Okay, there's a region. Now, how do we move a region? How do we translate a region? Let's see, I do not know how to do this. So we've got a region and we want to change its underlying coordinates. And when in doubt, read the documentation. Displays as a region. Okay. region distance, to give the distance from a point to something. Let's look at the guide for region properties and measures. Let's look at the one for geometric computation in general. How do we, transformed region. Image of the transformation. Okay, that's what we're going to want. Okay, f as a function. Okay, I think this should work. I really think that should work. Okay, so let's do translation transform of this thing here. And then we want to say transformed region of our femur here. And ta-da, well, there's another bone. See what happens if we say region of. I'm trying to put the two bones on top of each other. Actually, let's do region union just for fun. So region union of this bone, which is the translated left femur. So we want to do that bone together with, oh, weird and funky, look at that thing. Oh, that's pretty wild. It's cool. Okay, so that's what would happen if you took, actually I'm really curious now. I have had some silly problem with my foot, which thankfully has gone away. A case of plantar fasciitis. So let's see, I just wonder whether we actually have plantar fasciae. Do we have those? Come on, wake up, are we going to find it? No, dear. There must be a tendon. Let's take a look. It is my left foot that was giving me trouble. In fact, this allows me to demo something that's cool and new. Okay, so we have anatomy plot 3D of the left foot, and now I'm now really curious to look at this. I should have looked at this when my foot was hurting. Okay, there is the foot. I want to see underneath my foot. Okay, there's a great big muscle there. Oh, that's where it hurt, I think. Right there. Humph. Fancy that. And that somehow attaches into the bone there. Actually, now I'm curious to see whether, okay, now how do I think I can label this, but before I label it, I can just I can use a plot theme here. And what kind of plot themes? Oh, wow. That's cool. Okay, so let's do, how about we do scientific here? I have no idea what a marketing plot theme for a foot anatomy image is, but who knows? Okay, so this is now going to use a different plot, a different set of theme colors for the foot. Come on, wake up, foot. Come on, there's nothing wrong with your foot. Okay, never mind. Okay, come on, wake up. What's it doing? Oh, there we go. Okay, so now let's actually look underneath the foot. Ooh, that's interesting. So there are two different, oh, look at that. Oh, look at this. This is good. Okay, so this is the left flexor digitorum brevis. Okay, so methinks that was where my foot was hurting. This is very interesting. Okay, at least to me. But what I was going to do here, and that must be, what is that? The left calcaneus, yeah, okay. So let's actually do that. Left calcaneus. Actually, I'm curious now to take this image and to try to slice into that image, and just to see what it looks like if we kind of go into the foot, so to speak. So I think what we should be able to do here, oh, skin style. Okay. Oh, let's see what happens if I go skin style. I think if I do that, actually now I'm curious what the foot looks like if I do skin style to automatic, and I wonder what my foot is going to look like then, or this foot is going to look like then. So that will probably have, an opaque, a transparent layer. I think it takes a while to load this picture because it's got a lot of detail. Oh, great. Well, That's what did I do here? That seems very odd. That is a left foot, but I don't know why it added all that. That looks like a bug to me. Skin of the left big toe. I think the problem is that that skin is somehow connected, but that's really weird. That seems like it's a bug. Though maybe not. All right, the left calcaneus. Let's get its mesh region. I'm curious about this just because it's messy, messy, messy. So that's a discretization there, and that must be the attachment point in there of that must be the attachment point there of the tendon. And actually, if we go look up here, that was the left flexor digitorum brevis, which I might have to type in. Left flexor digitorum brevis. This is a place where we need auto-completion in these. See whether that actually comes up with anything reasonable. Come on, wake up. Oh, horrifying. Maybe I misspelled something there. Let's go to an environment where we can actually see that. Let's go to Wolfram Alpha, and I've got to stop hacking soon, but let's see what we can do here. Well, that's interesting. Maybe I'm totally digitorium. Well, let's see. I don't know what the flexor digitorium. That is very confusing. Okay, well, let's do this. Muscles of the left foot. When in doubt, let's see. Musculature of the left foot. Great. Now, let's find, what is it called? Let's try entities. Let's see whether that is not an entity. Okay, great. What do we want to do here? Well, worst case, we can just ask, let's see what properties this has. Whether regional parts is, or is there a thing called just parts or something? Again, when in doubt, we could always, let's see whether that's the relevant thing. I don't know if that's going to be the relevant thing, but let's try it. Missing, not available. Not good. Let's see. Okay, muscle count muscles. Maybe that's the relevant thing. I mean, if it's the musculature, surely it is the muscles. Okay, set of intrinsic. What the heck is an intrinsic muscle versus an extrinsic muscle? I do not know what those things are. Okay, let's see. Oh, come on. The dorsum of the plantar part of the left foot. That sounds like my problem area. So let's give that one a try. I think we could do this in Wolfram Alpha. First layer muscles. Well, okay, let's just do an anatomy plot 3D of those. Just to see what we've got here. Ooh. Okay. Interesting. Ooh. Okay. So those look like they're a bunch of muscles that connect to the toes. But let's see whether, does this one have, yeah, I think if we do this, line 94, if we say anatomy plot 3D of line 94, and then we say plot theme arrow scientific, it seemed to have tooltips that said, actually, you know what, this is not the right way to do it. That seemed to have tooltips that said what the muscles were, but I'm sure we can get this labeled. Let's just find out how to label it. There must be a way to label this. Humph, where is it? Options. I thought there was a way to label these. Anyway, maybe not. Okay, so this is these various muscles. This is that left abductor, left flexor digitorum brevis, which I think in my particular case is somehow unhappy, although fortunately it seems to have gotten happier in the last day or so. I think there are some tendons there as well, but we can also, so you know, it's interesting to, we can pull these out and do the computational geometry of these things. I mean, let's take, actually it's kind of interesting maybe to try and take these, take the, for each one of these, let's take entity value, let's just try and see whether this works. Mesh region of that, see if that worked. Okay, there we go. And it's kind of an interesting thing maybe is to try and see the volume of each of those. Interesting. Oh, maybe we just know the surface area. Maybe this is just the let's just go surface area of line 97, and then what? Oh yeah, that's kind of fun. So we can do, we could say sort by on line 97 the area, musculature of the bottom of the foot sorted by area, which is kind of interesting. Okay, any let me see, any other things people would like to hear about or look at, and then we're going to wrap up. I mean, there's a lot of new stuff in very classic areas, like here's a new thing in calculus. If you do, so if you have, let's say you have a function. Let's do plot sine x plus sine, let's do x sine square root of 2. No, what's a good one here? Let's try this. Let's say x plus square root of x. Is that going to do something interesting? Or is that going to be completely boring? That's going to be completely boring. Actually, what we want to do is this times, how about this, times cosine plus cosine x minus, no idea what this is going to do, square root of x. Okay, that's funky. Alright, let's do this up to 30, let's do it up to 100. Okay, so now the question is, if we say, what's the limit? So we got this function here, right? And if we say, what's the limit of that as x goes to infinity, it's going to tell us it doesn't. Oh, it's just going to tell us it's somewhere between -4 and 4. How can it be as big as -4? How can that possibly be the best it can do for this? How can that happen? Oh, maybe in the complex plane? No, in the complex plane it can do all kinds of crazy things. But anyway, what we can do here is to say max limit, that is the lim sup. And it doesn't like it. So sad. Well, what I was hoping it was going to show us is that, let's just do something it surely should be able to do. Oh, that's lovely. Look at that. Isn't that lovely? Oh wow, that is so cool. Okay, let's try it. Let's see what this is doing. I don't really understand why it was so complicated, but let's just maybe if we look at a picture, we'll find out why it's so complicated. No. Well, maybe what's happening there is that is a very, very, very complicated way. Let's do a full simplify of line 107. Grind. No. Okay, let's see what the numerical value of that is. 1.41. Oh, interesting. Oh, so that is, oh yeah. Thing is periodic, but its maximum value, though this is really cool, its maximum value is this very complicated mess. I don't know if that's obvious. Certainly not obvious to me. Definitely not obvious to me. And now, is that number something we would recognize? I mean, we can just try line 109. Let's do it to 100-digit precision, and let's say root. I mean, I don't think it's probably a number. Actually, you know what? When in doubt for something like this, just take the number and take a bunch of digits and go to Wolfram Alpha and just enter the digits. Eventually we'll have this capability in Wolfram Language, but we don't yet. And now our servers will go and try and look up. Alright, so it's a multiple of pi, it's the inverse hyperbolic sine of this weird combination of things. I would say this was not a convincing example of something that has... Actually, I'm now curious what happens if we say root reduce of line 109. Will it do anything? No, it did absolutely nothing. What happens if we say trig expand of line of that? Is it going to do anything? It makes a huge mess. Well, that wasn't very interesting. My gosh, what a mess. Let's try and give it something horrible here. Let's say full simplify that, see if it can simplify it at all. It probably won't. But oh, it did! It did! Look at that! Oh, wowee! So, turns out, this thing here, line 102, that 112, that's kind of interesting. Actually, I'm now curious what happens here. If we say full simplify line 112, does it manage to find that simplification? No, it doesn't. Now, I wonder why it doesn't. Maybe it doesn't because its time ran out. Let us just see. Time constraint is infinity. Okay. I wonder why it doesn't find that. It's very interesting. Fascinating. I haven't seen one of those in years, of something which can be found. So what's happening is that a series of transformations can find the simpler form, because what has to happen is you have to basically in first approximation, you're kind of, it's like theorem proving. You're kind of treeing out possibilities to try and find these different forms. Interesting. Okay. Okay. Somebody's asking, will any new features help with enumerating theorems and possible proofs? Actually, since you ask, something very exciting is coming along those lines in the next version. Do I want to... I don't think I can preview that yet for you guys. I don't think I have a version that will preview it, but I will show you one thing that kind of is an illustration of things to come there. If I go to our data repository, let's see, I will show you what it's going to look like roughly. Okay, so here's the data repository, and if I go to things in the computational universe, let's see, here we go, proof of an axiom system, Boolean algebra. Okay, so let me show you what this is going to look like roughly. This will be a proof that you get by just saying prove. In this particular case, if I think I have this in the full simplify implementation. Let's take a look here. Here we go. So this is what we can do right now. This is my axiom system that I found about 20 years ago now, for actually 17 years ago now. It's an axiom system for Boolean algebra. It's the simplest axiom system for Boolean algebra. And here what I'm doing is to say prove the commutativity of NAND effectively from the axiom. Okay, so that's not particularly informative. It just says it's true. What if you want the proof? Well, a big question for us for many years, in fact ever since I did this proof, because we had an automated theorem proving system, because, and this is, let me show you that proof. This is a version of that proof as a data set. And so what you see is these are lemmas, and like this there, that there is the proof of the lemma. So for example, in this case, what I can do is I can say, for the statements here, I can say, well, even if I just say, let me do this. Let me take the, here, let me do this. Let me say, let's see, line 17, that resource data. So each one of these is a lemma that here, let's do this. Let us say this thing all comma statement. Not going to work. Okay. And now let's do, I think they all seem to have a single thing on the, well, no they don't. So let's take the first 5 of those. And now let's take a normal version of that. And let's do this, and let's just show the tree forms of those. Oh, that's very silly. How do we make those into good expression trees? I wonder if I'd had a way of doing that here. Tree form, oh, vertex labeling false. That's a good way to do it. So tree form of this, vertex labeling to false. And let's do that for line 121. And so what this is now showing is the trees corresponding to those expressions which were part of the lemmas. So actually what I'm going to do is I'm going to dig down. So I want to say normal of %119. And then what I want to do, okay, that's a big mess. What I want to do is to do this tree form thing. And what I'm going to do is I'm going to say map that tree form thing onto that normal thing at level 2, and let's see what that does. Okay, cool. So what that's showing is those are the equations, basically. Those that are being used at the intermediate stages of the proof of commutativity from this operation of mine, from this axiom of mine. So it's pretty complicated. This is pretty hard for humans to understand. I mean, this is basically, I see this as being kind of an analog of what happens in like a neural net, where it is figuring out certain kinds of distinctions to make, but they're not distinctions that we as humans happen to have words for. And so similarly here in the automated theorem prover, it's kind of figuring out the interesting lemmas to produce, but we don't have names for those lemmas. None of these lemmas was called, Brown's lemma or something. They were all they're all just machine-generated lemmas. Somebody's asking about Fokker-Planck equation of black shoals. I'm not going to go down this path very far, but let's just very quickly let's look at things like Ito processes. And okay, so this is an example. Define a process by its stochastic differential equation. So let's say we have a okay, well actually I'm just gonna crib this out of here. So this is an Ito process, and what are we doing here? This is an Ito process where that is a Wiener process, and I think, let's see what happens if I say random variate. What will happen if I do this? Is this going to do something sensible, or is this going to do something totally crazy? It's not a random distribution. Okay, so what I want is random process, maybe? No, that's not what I want. What I want to do is look at the documentation when I don't know what I'm doing. And, oh, random function, that's what I want. What do I do here? Okay, what do those parameters mean for random function? Random function gives a pseudo-random function from the process proc from tmin to tmax. Okay, so if I do this from tmin, I don't know what tmin should be, 0 to 10. Okay, cool. So that will give me, let's see what happens. Line plot, is that going to work? Yeah, there we go. So that is a sample Wiener process over that range. And I suppose what I could do if I wanted to, I could say list line plot of that. and I could like make a few samples. Let's make 5 sample Wiener processes. Okay, great. There are 5 sample Wiener processes. Now, this Ito process is going to be derived from the Wiener process using this stochastic differential equation here, because dw here is w is distributed according to a Wiener process. So this Ito process, let's see what happens if I do that. Now what I want to do is to say, I guess I would say random function. Would I say that? Random function? Not sure. Maybe this is something yet different. Maybe this is a higher order thing. Let's just see what happens if I do this. Yeah, there we go. Okay, so this is now going to make an Ito process derived from the so much for that. Oh, no, I'm sorry, that's just one of them. Whoops. List line plot. And now what I want to do there is to say table. Let's live dangerously and do 5 of them at a time, which might not work. But let's see. Oh, there we go. Okay, so those are Ito processes made from those Wiener processes. So what can we do here? We could say, for example, Ito process. Let's go back to the Ito process. Given that Ito process, we can compute all kinds of things from the Ito process. So, for example, given that Ito process, we could, well, this is computing the mean. Let's compute something a little bit more interesting. Let's compute the kurtosis of that that Ito process. Let's see if we can do that. Bluff. Let's see if we can compute the mean. Something's wrong here. Okay, hold on. Oh. Ito process of t. Ta-da! There we go. Let's see if we can compute the kurtosis of this thing. Wow! That's cool, in my humble opinion. Let's see what happens if we just plot that as a function of t from 0 to 10, for example. I see. It's got increasing kurtosis for some reason. Actually, what we should be able to do is to just make the histogram here. I wonder if we can do that. How would we do that? We would take one of these processes. Let's just take a Wiener process, because that's a nice simple kind of stochastic process. And let's see if we can just make, I wonder what happens if we just say, let's do this. Let's take a Wiener process there. Let's see whether this just works. Let's take a Wiener process and let us say histogram of that. That's good, that works. Okay, so let's try running it for a lot longer. Let's try running it 100 steps here. Okay, let's try taking it 1,000 steps. How about that? Okay, I don't understand that, but whatever. So now we could do the same thing with the Ito process here. We could take the Ito process and we could take, which is derived from stochastic differential equation, derived from sort of driven by Wiener process noise. And we could say 0, 1,000, 0.1. And then we close for the histogram. Okay. Don't understand that particularly. I'm just going to, just for the hell of it, I'm that number to a 10. Just see what happens. It got an overflow. Wow, it's really confused and hosed. Okay, so that was, let's just do two there. Let's try, just for fun, let's try just doing, I'm guessing if we do, let's do an abs there. I wonder if it will be able to compute that. Don't know if it will. Okay, that was cool. This is pretty fancy. I wonder what would happen if we had an x of t outside of that. Does it go bonkers? Yes, it doesn't do the same kind of thing at all. So if we do that and we say list line plot, see, I don't really know enough about Ito processes. I should know more. I think we have to do it for a smaller range. Let's just do this. Wow. Oh, okay, so this thing is basically dying. So if I were to do this and I was to say plot range, well, let's say list log plot and then join the points there, then my guess is this would be showing that this process, for whatever reason, yeah, it's okay. Okay, so it's decaying exponentially for some reason, which is probably obvious because probably that x of t is what makes it do that. And I bet if I change that to square root, I'm going to have to say square root of abs of t because I know it's going to go negative. If I said square root of abs of t, then this would look, wow, funky, weird. Why does it do that? Why does it do that? Oh, because it's gone negative, right. So it's the list log plot that makes it do that. Right. There we go. So that's a bit of stochastic calculus. All right. Fine. Okay, well, I think I should wrap up there. Well, I learned some things here. This was fun for me, at least. I hope people had fun. It's somebody's asking symbol W between Wiener process called. Oh, that's a distributed like symbol. Okay. Anyway, we should wrap up here. If people are interested, I might. I've been doing some Twitch sessions, do random programming for different reasons. So I might take requests for topics that people are interested in. Frankly, this is really educational for me. There are a bunch of different functions and options that I hadn't really played around with, and so this was great. Well, thanks all for coming, and look forward to twitching with you again.